Okay, in the previous video we went through generics. We also talked a lot about protocols, and also we talked about type aliasing those protocols. I thought I had a pretty good solution with this function here. I've changed this to the attackable, to adopt the attackable protocol. It brings in generic. But then I was thinking about it, and I think there's actually a better way. So this video, we're going to go over I think, an even better way of handling a generic when it comes into a function. And we might even get into refactoring this code a little bit to make it look better, function better, and maybe even be part of a structure. All right, before we get started, I just wanted to clarify something in the previous video. There was a point in the video where I was trying to cast a firebolt at the number 23, for instance. And in the video, we did something like this. We tried to cast the firebolt at the named item number 23. And it didn't like that because the int does not conform to nameable protocol. See, here's the function up here, and it requires it to be nameable. And I said, so you can't do that. Well, the truth is you can actually do that if you do something clever, like you make an extension for the int protocol, or for the int type. So extension int, and we're going to adopt the nameable protocol that we made in the previous video, and then it's going to ask, okay, fine, what is it? And we'll add the protocol stubs. It wants to return something, so let's have it return a string version of the int, right? So it's like returning a string like this, and self, something like that. See if it likes that or not. And so now here we go, whoosh, boom, crackle, you hit the 23. Okay, moving on. Now, my original favorite function is this one here. And, oops. Let's go ahead and paste that function down here below and take a look at it. So what are we doing? We're casting firebolt at, and the letter T is the generic, and we're having the T has to be attackable. Well, I want to make a function where there's no requirement. You can cast the firebolt at anything. I actually don't like the way this is worded either, so I'm going to cast the firebolt at something like that instead. And then it's not going to be called attacked, it'll be like at anything. Okay. And we can't, right now, anyways, we can't get anything's name because anything is not nameable, as we just found out in this up here. So what if instead of checking to see if it's nameable up here, we check to see what the heck it is inside of here. So inside here, we'll check to see what it is. And way I like to, originally I thought I'd use a switch statement, but if you use a switch statement, you can't really easily cast it as different items. Now let me show you what I mean. So first let's check to see if you can attack it. So if let, that's if let attacked. So we're creating a new thing if the condition is true. The thing is going to be possibly attackable. Okay, so now we're unwrapping something. We're saying if let this attacked thing, this new thing, be actually it should be anything because we called it anything up here. I'm going to change this to thing because I like the way that reads a little bit better. So, and you could do something like this as well. If let thing equal thing as attackable. But I'm going to be, I'm going to call it if let attacked object. No, just attacked is fine. So if let attacked equal the thing if it's attackable. So then we can be like, whoosh, boom, you hit the attacked thing, right? Whoosh, boom, crackle, you hit the attacked name. And we can use name because attackable adopts the nameable protocol. All right, so what else? If let a named thing, something that's named equal the thing as question mark. And the question mark, of course, means it's optional. Might exist, it might not. It might be nameable, it might not. And if it is nameable, then let's assign this new thing named in here. And then we got this little print statement here, whoosh, boom, Actually, no, this print statement here is whoosh. You cast at the blank, but not much happens. So this is like if it's got a name, but it's not attackable. And the last condition is just going to cover everything else. So we can just do else, not self, else. And this is going to cover things that aren't nameable and they're not attackable, and you really can't do that. So, you can't cast Firebolt at that. Okay, so we can get rid of this print statement down here below. And now what we've got is a pretty good function here. So now we can pass whatever we want into this function, and if you can attack it, it's going to hit it. If you can't attack it, but it has a name, you cast it and not much happens, and everything else, you just can't do that. So let's go ahead and give this a try. And so it's cast Firebolt at, and let's cast it at the air. Not much should happen with the air. And I'm going to take out these other print statements here so we're not confused. Or these other functions, I'll just not call those. So let's see what this does. Whoosh, you cast at the air, not much happens. Okay, cool. Now if we cast Firebolt at the orc. So this is supposed to be cast Firebolt at orc. And let's see here. Boom, you hit the orc, boosh, boom, crackle, awesome. And now finally, let's just cast it at something that's really weird. Cast Firebolt at Don Johnson. You can't cast Firebolt at that. So you see how we're handling three different options here, three different things. We've got one function, and it's switching, or it's not switching, but it's if-elsing inside of here and unwrapping the item as the different types. So this is a pretty handy way of doing it. You can also check to see if things are structures or classes in here and unwrap them accordingly there. And so I feel like this is a pretty solid way of handling a generic. You can pass anything into it, and it's going to unwrap as needed. But then I thought, well, what if I want to cast something other than Firebolt? And I took this whole example a whole lot further. So the first thing I wanted to make then is I'd like to have ultimately, I'd like my function to look like this. I think the function should eventually look like this. There's a spellcaster dot cast Firebolt at orc. Okay, I think this is expressive and simple, reads well. That's what I want it to look like. So the first step is we got to make a function that takes a spell in. But in order to get a spell, then we need a spell structure, right? So what does a spell have? Let's make the structure for a spell. Making a structure is pretty simple. You just type in string. Just kidding. Making a structure is pretty simple. You just type in struct. And then we're going to make it a spell type. Open, close curly braces with a variable called, well, it's going to be nameable. So we'll just have it adopt the nameable protocol and then have it fill in the stubs for us because I'm lazy and I just like doing that. Boom. And then the other thing that spell's going to have is a little different. It's going to have damage. So we'll just say that's an integer of how much damage the spell deals. And then because I'm a D&D guy, it's going to be a damage type also, damage type. Ultimately, this would be an enum, but just for now, let's make it a string. Great. There's a spell type. Now let's create a couple spells here. We want the magic missile spell and a firebolt spell. So I'm going to type that out for you. Okay, we got a couple spells now. Now it does say here it wants us to create a function to cast the spell using a generic if and if let. All right, so let's do that. So the function I like is this function up here. So that's my favorite function so far. So we're going to copy that one and we'll paste it down here. And instead of cast firebolt, we're just going to say cast. And then we'll put the spell part in here. It's of type spell at the thing. And that's pretty good, right? Whoosh, boom, crackle, you hit blank, hit the blank with And then let's cast in the spell name also. Let's put in the spell name. Spell name. You hit the blank with spell name. You cast the spell. You cast spell.name at the blank, but not much happens. You can't cast, and then we'll put the spell name in there. You can't cast the spell name at that. All right, let's try to use it and see what happens. So all we got to do is just type in cast. Our new one is here. Cast spell magic missile at orc. Let's run this, see what happens. Whoosh, boom, crackle, you hit the orc with magic missile. Now, I think this could be even better. Like, I want it to look like this instead. Like, if you're casting, it's obviously going to be a spell, so we don't need the spell descriptor up there. So to do that, you just put an underscore before the descriptive word here. I forget what this one's called, but this is what it's referred to inside the function, and this is what it's referred to outside the function when you're calling it. So that's why I've got at here. So see, at shows up here, but inside the function, it's called the thing. So now, cast magic missile at orc. That's pretty good. And we could also cast firebolt at door or something. Okay. Make code even more awesome. Let's put cast inside of a Spellcaster protocol. So yeah, I was thinking, well, it would be better if, like, who's casting this? You don't know who's casting it right now. So it would be better if there was a Spellcaster protocol, and whoever's a Spellcaster has the ability to cast spells, right? So protocol, Spellcaster, open and close curly braces. And to make a function, it's pretty simple. You just do function, and then we want this cast function. And put simply, when you're doing protocols, you just have to do this. But because our cast function is so fancy schmancy up here, we gotta grab this instead. So I'm going to copy this part here, and we'll plunk that in there for the function. So now anything that's a spellcaster has to adopt this new fancy casting casting function. Great. So now we can do cool stuff, like let's make a wizard. And I went ahead and typed all this out. I want to save you some time, and I'll uncomment this, and let's go through it. Now this first piece is, we'll come back to this first piece a little bit later, okay? But essentially, the spellcaster is a wizard in this case. So here's the spellcaster protocol. A wizard, it's damageable, targetable, nameable, and it adopts the cast protocol. And the cast protocol is pretty much exactly the same as the one that's above. Very similar, and that's all that's to a wizard. So now, cool stuff we can do is we could, instead of using the cast function here, we can create a wizard. So let Raistlin equal wizard, and the wizard's got, let's say it's got, I don't know, 65 health. His name is Raistlin. Now, because wizard adopts the spellcaster protocol and it's got this function inside of it, we can do Raistlin.cast spell firebolt at orc. Sweet, right? Now, what if Raistlin gets hit and takes damage? That's the next step, right? So I made a little function here, a simple one, and this is not the best way to do it, but I made a function to take damage. And in this take damage function, we've got we have to create a new damage thing, because you can't modify this one because this is a let. Like any of these arguments that you pass in are constants and not mutable. So you have to create a new thing from this constant thing. And this was the variable one. And then I want to change the health of that thing, but it's like you can't do that because health is a get-only property. So we scroll way up here to damageable protocol. When we initially declared it, we wrote down that damageable can get things, but we did not say that damageable things can be set. So you just have to put this little set thing in there, and now you should be able to set the damage as well as get it. A little bit special. Okay, so now the damage thing is health, and it can be adjusted, and then we just return that damageable thing. So I didn't like this function, so I wanted to make it simpler. So I did this next function here, which is I'm using something different. It's called an InOut. So in this case, the function takes in something that's damaged and InOut, and it's like the same function up here, but because we're passing something in damageable and we're getting something out damageable, see how they're both there? You can call this InOut thing, which means like this thing is going in and out. And now it takes the damaged object, it subtracts the health from it, and spits it out again. Okay, so let's try this InOut function really quick. First, let's set Raceland's health to 100, just so we know. Okay, so Raceland's health is at 100, and then we're going to go take damage. And you'll see it auto-filled this little and symbol there. That's important. We're going to put in Raceland, the title there, and then we'll subtract maybe 20 hit points from Raceland. Go ahead and print it out now. Raceland's health. Okay, so let's go ahead and run it. It should be at the very bottom there, 80, I would think. And there we go, 80. So this is an option, right? An InOut. It's something new. You pass something inside of it and get something out. Now you'll notice I changed this to wizard up here as opposed to damageable because it wants something very specific to go in and something very specific to go out. So for that reason, nope, don't like this solution either. Let's take this to the next level. So then I was thinking, well, what about this damageable protocol? If something is damageable, maybe we need to put like a function inside of the damageable protocol. And that function will be something like this. Mutating function to take damage for an amount, right? A mutating function to take damage for an amount. Then what we could do is inside of like things like objects, we can say something like this. Take damage for the amount and then adjust the health. Health is equal to health minus the amount. So now anything that's a damageable protocol has to adopt this mutating function to take damage. And I feel like this is now starting to look much better. So let's kill Raceland here. So take damage. Raceland takes damage for 190. And then let's print out Raceland's health down here. Negative 125. Raceland is dead. So hopefully this was helpful for you. This is the final structure that I've got for now. Of course, maybe we'll have part 3 where I make this even better. But I think for now I can live with this. We've got a function that takes in a generic and then acts differently based on what kind of thing is passed in there. And we've got a mutating function, a mutating method, I guess you call it, inside of this structure here for the wizard to take damage. We also made a Spellcaster protocol which adopts this casting function up here, which is pretty cool. And so all so that we can do something cool like this. Raceland cast firebolt at orc. Raceland take damage for 190. And if this was helpful for you, give it a thumbs up, like, subscribe, and until next time, everyone stay safe out there.